Okay, guys, we're going to review a few things about the periodic table and about periodic trends. So first thing I want to talk about is just here's a periodic table, right? Because we're getting ready for comps. So I just want to review these topics because it's been a while since we talked about them. So let's just talk about the periodic table and kind of how it's organized. So if you remember, there are columns, and these columns here are called groups. Okay, so these ones are called groups. So this is like group 1, group 2, group 3, blah, 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 okay? And then these things that go horizontally are called periods. Okay, that's why it's called a periodic table, okay? And the groups tell us a lot about their specific bonding properties. So, for example, all of these in group 1 have 1 valence electron. All these in group 2 have 2 valence electrons. And then we skip over these because these guys can vary because they're transition metals, right? And these guys, honestly, we're like never going to talk about these this year. So I always get questions from students asking about these inner transition metals. They're not super applicable to what we're talking about 99.9% of the time. So we're just going to kind of not worry about them. So groups, so these will tell you how many valence electrons they have. So these have 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, 8. And just to remind you, a valence electron is electron in the outermost energy level. Okay, the outermost energy level. Those are the valence electrons. Those are the ones that have to do with bonding. Okay, and let's look at where everything's organized. So if you remember, there's a staircase or a zigzag. I'm going to do it in green, actually. So this staircase, okay, this staircase separates your metals and your nonmetals. So generally, all the stuff on the left of the zigzag are metals. All the stuff on the right of the zigzag are nonmetals. Okay, so it's important to realize there's a lot more metals than there are nonmetals, right? So these ones are metals, and these ones are nonmetals. Oops, nonmetals. And then a bunch of these ones are what we consider metalloids, and I just like to think of them as the ones that are touching the zigzag. Now, there are, as with everything, there are a few exceptions. Like I think these ones are considered metalloids. These ones here, and then there's some debate with some of these guys in this region, depending on what website you're looking at, which one's a metalloid. The main ones you need to know for sure are metalloids. Like the big one actually is like silicon, because that's a big one that's brought up a lot as being a metalloid. And boron's a metalloid, germanium's a metalloid, antimony's a metalloid. But some of these are kind of up to debate. Okay. But other than that, everything over here is a nonmetal. Everything over here is a metal, with the exception of course, hydrogen, which is a nonmetal, even though it's over here with the metals. Okay. Okay, so there's our metals and our nonmetals and our metalloids. So let's talk about properties of metals versus nonmetals, etc. So let's talk about properties of metals first. So all these guys are metals, with the exception of hydrogen. Metals are good conductors of heat and electricity. Okay, good conductors of heat and electricity. Okay, that's why oftentimes when it's hot outside and you go to get in your car, you touch the metal part of your car and it burns. Ouch, because it conducts heat really well. But if you touch like the plastic part or like the cushion on your seat, it's not going to burn you. Okay, it's because metals are good conductors. Ductile means that metals can be stretched into wires. Think about the copper wires that are inside the wiring of your home. Malleable, meaning metals can be bent. Okay, if you bend it or you pound it into a sheet or something, think about like aluminum foil, things like that. It doesn't break, it bends. It can be molded into different shapes. Lustrous means metals tend to be shiny. Okay, so if it's lustrous, it's shiny. And metals lose electrons in chemical reactions, meaning they form positively charged ions. Okay, so metals are positively charged ions. Okay, and if you remember the charges that you should have memorized, if you don't, holy cow, where have you been all year? Okay, these ones are +1, these ones are +2. Skip, because remember these are transition metals, their charges can change. These ones are +3. This one, don't worry about it. -3, -2, -1. Those are the charges you need to know. 1, 2, 3, skip. 3, 2, 1. Okay? And that becomes very important when we talk about bonding and stuff. Okay? So you'll notice that the metals are the positive ones. Okay? And this +3 here applies to these guys, if you remember, because we have a little triangle that we drew when we were talking about charges. Okay, and we know that these guys are +2 and this is +1. Those ones we have memorized. These guys are metals, but they're what's it called? Charges can change, remember, because these guys are kind of considered transition metals along with these. All right, so these -3, -2, -1 do not apply to things like bismuth and stuff. Okay, so last thing is solids at room temperature. So metals tend to be solid at room temperature. The exception would be mercury, which is a liquid at room temperature. But other than that, all the metals are solid at room temperature. So there's some properties of metals. Properties of nonmetals. So remember, nonmetals are over here, and hydrogen. Nonmetals are good insulators, meaning they do not conduct heat or electricity. Okay, they can be gas, liquid, or solid at room temperature. Like the noble gases are obviously gases. Okay, but then you get something like carbon that's solid at room temperature, so it kind of just depends. Solid nonmetals are brittle, not lustrous. Okay, so again, think of something like carbon. Think about the graphite in your pencil. That's a nonmetal. It will break if you try to bend it. It won't bend, it'll break. Okay, that was what it means to be brittle. It's not shiny, it's not lustrous. Nonmetals gain electrons when they're in ionic bonds, so meaning they make negative ions. So these -3, -2, -1, when they're in an ionic bond, they're going to make negative charges. When they're in a covalent bond, they share electrons and there is no charge. Okay, like H2O, right? Okay, last thing is metalloids. Metalloids are the properties of metalloids are not super. It's not a very long list because it kind of just depends on the metalloid you're talking about. That's why they're called metalloids, because they don't really fall neatly into one of these two categories of metals or nonmetals. They're really similar to metals. They're really similar to nonmetals. So they can be shiny, they can be dull, they can be brittle, they can be malleable. Silicon. This is a big thing that's brought up a lot. Is that silicon is a semiconductor, meaning it conducts electricity sometimes, but not all the time. So it's used for things like computer chips and stuff. But you'll mostly be asked about properties of metals and nonmetals, not so much about metalloids because there's so much gray area there with metalloids, okay? Okay, the other big thing I want to talk about was periodic trends. Periodic trends. So there are 3 big trends you need to know. Big 3. Okay, atomic radius, electronegativity, and ionization energy. First one is atomic radius. Atomic radius. If you remember, atomic radius, it's half the distance between the nuclei of 2 atoms. So basically, it's just the radius of the atom. So if here's my nucleus, right, and you got all these electrons around it and the electron cloud, it's exactly what it sounds like. It's the radius. Okay? How big around is the radius of the atom? Okay, and if you remember, we memorized how we can figure out where the atomic radius gets larger, and that is towards francium. Because remember, when you go to France, you eat a lot of food, and when you eat too much food, you get really fat. Your radius gets really big. So as atoms get closer and closer to francium, they have a larger atomic radius. So I'm just going to draw arrows down here. So as you get closer to francium, down and to the left, the radius increases. Okay? Electronegativity is the measure of the ability of an atom in a chemical compound to attract electrons. So basically it means, I always like to think about it as if you have a high electronegativity, you're very greedy with your electrons. You hold onto your electrons really tight. Okay? And you don't want to give up those electrons. So the electronegativity trend is the opposite of the atomic radius trend. So it goes up and to the right. Okay? Ionization energy is the energy required to remove an electron. So it's very closely related to electronegativity. And atoms that have very high ionization energy are atoms that are going to hold on to their electrons tightly, like electronegativity, and it's going to take a lot of energy to remove those electrons. So the trend is the same for ionization energy, because these two things are very closely related. And they're inversely related to atomic radius. Okay? So those are the 3 trends you need to know. So, and you need to know how to basically answer questions about them. Okay, so let me do some example questions real fast. So the first example says, which element has a larger atomic radius, sodium or lithium? So sodium or lithium, which has a larger atomic radius? Well, atomic radius increases towards francium. So which one would have a larger atomic radius? It would be sodium, because it's closer down and to the left, right? So sodium would have the larger atomic radius. Okay, example number 2 says, which element has the higher electronegativity? So remember, electronegativity increases up and to the right. So let's see, sulfur or chlorine, which is further to the right? Chlorine is further to the right. So it's this one would have higher electronegativity. Okay. Example number 3 says, which element has a higher ionization energy, carbon or nitrogen? Ionization energy also increases up and to the right. Okay, so carbon or nitrogen, nitrogen would have a higher ionization energy because it's further to the right. Okay. And example number 4, all right, so this doesn't necessarily have to do with trends because it's saying which has a larger atomic radius, magnesium or magnesium that's lost 2 electrons with a +2 charge here. So if you remember, a +2 charge means it's lost 2 electrons. So it's not so much about where it is in the periodic table because we're just looking at magnesium and we're comparing it to its own ion. So we have to think about if it has lost electrons, if it has lost some of these electrons, it's going to get a radius that is smaller. So this is going to be smaller than this. So this would have your larger atomic radius. Okay, so it's a little opposite of what some people think. If it has a positively charged, if it's a positively charged ion, it's going to be smaller. Okay. And vice versa. If it's a negatively charged ion, it's going to be bigger. So this one's saying which is a larger radius, bromine or a bromine ion. This bromine ion, again, it's kind of hard to see, but that says -1. If it has a -1, that means it has gained an electron. So this one would be larger. Okay. So negative ions or anions are larger. Positive ions or cations are smaller. Okay. All right. Go ahead and finish the assignment that accompanies this for a little review for you, and that is it.